Let's go through this build your understanding problem. To determine the quartiles, we start by determining the median. And I've already counted the number of data values here. There are 21. So the middle data value is this 30.95. It's got 10 data values below it and 10 above it. So that's our median, also known as quartile 2, 30.95. Now below that are 10 data values, so that's an even number, so the quartile 1 is going to be the average of, it's going to be the median of these, so it's going to be the average of the two middle ones. So let's see where that would be. I think those are our two middle ones. Yes, okay. So Q1 will be 25.83 plus 26.28 divided by 2, which is 26.055. And I'll round that to the same number of decimal places that our data values had in our data set. So 26.06. Oh, and that's Q1. Q3 will be the average of the two middle numbers in the upper half of the data, which I believe are those two. Yep. And so that will be 37.05 plus 37.43 divided by 2, and that is 37.24. So our interquartile range, which is always Q3 minus Q1, will be 26.06 minus 37.24, or 11.18. Now the lower fence is Q1 minus 1.5 times the interquartile range, which is 26.06 minus 1.5 times 11.18, and that is 9.39. Our upper fence is Q3 plus 1.5 times the interquartile range. So that's 37.24 plus 1.5 times 11.18, 54.01. So, are there any outliers? Well, there are no data values below the lower fence, 9.39, so there are no outliers in the lower end, but this 54.63, that is larger than the upper fence, 54.01. So we would say then that, I'm kind of running out of room here, but let me put it here. So we would say that based on our lower fence and our upper fence, 54.63 is an outlier. I don't know if you noticed the box plots below this problem. The first box plot is the one that you would make if I had asked you to make a box plot. Now the scale is so detailed in terms of our data and so undetailed in terms of our horizontal axis that it's hard to tell exactly, but this quartile 1 is at the 26.06 mark. The median that shows up here is our 30.95. and quartile 3 is what we discovered it to be at 37.24. The lowest data value was 19.95. It's hard to tell the difference between that and 20, so I'm just going to let our lower whisker be pointing down to 20. It's maybe a little bit to the left, but it's hard to tell a difference of 500ths on here. And the upper whisker is pointing down to our largest data value, which was 54.63. So that's the box plot as we're used to drawing them. Now there is another way that people do box plots to indicate when they think a data value is an outlier. So this next box plot is exactly the same. We've got our lower whisker ending at 19.95, although it's hard to see the difference between that and 20. And then we have our quartiles at 26.06, 30.95, and 37.24. But the upper whisker ends below 50. So where is it ending? Well, it's ending at the highest data value that's not an outlier. So this is actually ending at 49.17. And then what people will do is put a dot or an asterisk usually at the data value or values that they're saying are outliers. So this asterisk would go above 54.63, and the whisker would not extend that far. On the lower end, we didn't have any outliers, and that's why the lower end of both box plots looks the same. I'm not going to ask you to do a box plot showing outliers. That's too fiddly for us, but I want you to understand what you're seeing if you see such a box and whisker plot. One other difference you might see if you're looking at box plots in a news article or a paper or whatever is they don't always have these vertical doodads at the ends of the whiskers. I like having them there. I think it makes it a lot easier to look down and see where the whisker ends, but you don't always see those. So oftentimes what you'll see is going to look more like this. Before we leave the topic of box plots, there's kind of a nice graphic comparing histograms and box plots that I wanted to share with you. What they've done is they've taken 3 data sets and for each of them made a histogram, and they've also made a box and whisker plot for it. So we can get some idea of how those two sorts of things compare. If you look at the first one to the left, you see that you get, in some ways, a better visualization of the data looking at the histogram. You can get a better idea of how many data values are in each class, and you get a nice view of the fact that it's skewed to the right. On the other hand, there's things you cannot tell from the histogram. You can't tell where the minimum and maximum data values are. All you know is that the minimum one is in that first class and the maximum one is in that last class. Whereas the box and whisker plot shows directly where the lowest value and the highest value are. Also, you can't really tell from the histogram where the median or the mean are. Now you could kind of guesstimate, but it's really hard to tell. Whereas the box plot tells you exactly where the median is. Now it doesn't address the mean, but it shows you right where the median is. And also notice in the box plot, you can tell that this data is skewed to the right because the whisker on the right goes off much further from the center of the data than the whisker on the left does. Moving over towards the middle picture in the diagrams, this is a symmetric data. Now with symmetric data, looking at the histogram, it's a lot easier to get an idea of where both the mean and the median are. They're pretty much going to be in the middle of the horizontal axis. But again, The box and whisker plot shows exactly where the median is and gives a better idea of the range, the minimum and the maximum. Then the last one is for a data set that's skewed left. So really I have pretty much the same comments there as I did for the one that was skewed right. Now, which type of visualization is better? Well, neither one is better. It depends on what you're trying to convey. What do you want your viewer to be able to deduce from your visual representation of the data? And how can you make that clear to them?